Hi everyone, it's me, Carolyn, and I'm going to be doing another binomial distribution example. I am going to use some statistical software and some technologies, namely Excel and StatCrunch, to help me get the answers. But I'm also then going to move into how do we find the mean standard deviation of a binomial. Luckily for us, the formula for doing so is quite simple. And I like to use this kind of a problem to introduce that. But here is what we have. We have a survey that found that 20% of all consumers prefer whole milk to other types of milk. I should probably wrote that in here, types of milk. And we are going to take 10 people randomly selected, and I want to find out two pieces. What is the probability that 8 of the 10 people prefer whole milk? Or this one, what is the probability that fewer than 4 of these people prefer whole milk? And some of you may be sitting out there thinking, well, this is not a binomial, but I will tell you, yes, it is. It doesn't, it's not our flipping a coin 5 times, rolling a die 17 times. So it's like, well, where are these trials that we're talking about? Well, the trials that we have are the 10 people that we're looking at. So every person, those 10 people, you're going to ask them the question, what type of milk do you prefer? And they're going to give you an answer. So those are our finite number of trials, is these 10 people. Are they independent from one another? If they are randomly selected carefully enough, yes. If you do a simple random sample, you should be getting 10 independent people that do not interact with others. If you start getting too many, then we might have some issues, but if you just take 10 people off the world, pretty unlikely that they're going to be related somehow. The third step was that we have 2 outcomes. Here we are looking at, do they prefer whole milk or something else? We've narrowed it down to whole milk and grouped everybody else as a failure. Our probability of success has to remain consistent, and this is where we're going to use this 20%, because it says 20% of all consumers. So the probability that you like whole milk should be 20% in its decimal form, or 0.2. So if on this problem we're trying to find what is the probability that 8 of these 10 people prefer whole milk, I'm going to kind of remind us of some things. So we're looking probability x is equal to 8. And I could put the formula out here. I'm not going to. I'm just going to remind us of the pieces we're going to need. Our n, which is the number of trials, that's 10. Our p, which is the probability of our success, is that 20% in its decimal form. Okay, and here our x is just 8. And I will go in a little bit to some technology and we'll get those values. Here we want to do probability that fewer than 4 of these people prefer whole milk. So fewer, so that means less, right? Less than 4. Now, does that include the 4? If I go fewer, that would not include the 4, because it would be, we would want at most 4 or less than or equal to 4, but fewer means we're strictly smaller than 4. Okay, and again, I'm going to now go to get some software and remind us how we use the software to do these problems. So I'm going to stop sharing here and share. First of all, we will go into StatCrunch, which is one program that some of my classes do get to use. It is a Pearson product. But to remind us, we go into Stat underneath the calculators. So stat calculators, we're going to binomial. And I do like this one. Don't like the fact that it pops stuff up on me, but, and you guys may not have seen that, so that's great. So we have 10 people. Our P is not 0.5, but 0.2. Okay, and we want to go equal to, the first one, equal to 8. And we're going to compute that. Okay, and you can also remember this does show us the graph. It doesn't even go up to 8. And the reason for that is you'll notice that as we get higher and higher, the probability of getting those values is pretty small. In fact, we do have a very small number. It's 0.0000, so 407373 for that value, and 8, so you can barely see the little dot up there. So the fact that 8 out of our 10 prefer whole milk is a very unlikely event, because unlikely was our magic. Unlikely is that 0.05. You'll notice as soon as we get past 4, those are unlikely events. Okay, and that makes sense because only 20% of the population, or the survey found that 20% of all consumers like whole milk. So if we have groups of 10, having 8 of them, that's quite a big difference. Okay, the next one we had was strictly less than, and the number was 4. And you'll notice here, I'm going to write this number down too. So when I go to Excel, 0.879126112. Okay. Strictly less than 4, you'll see that we are adding 0, 1, 2, and 3 up to get that 0.879, so forth. Okay, so hopefully that was a quick reminder of how we use StatCrunch in helping us with that binomial. I am going to stop this sharing, and I'm going to go into Excel and remind us how we do it in Excel as well. So here we are in Excel, and I'm just going to grab an empty, I'm going to do first of all x equal to 8. And then we also want to do x strictly less than 4. All right, so to do this, x equal to 8, kind of remind us under our function button, we want to make sure that the statistical category, or if you're in the all of them, it is alphabetical. You might have to look through quite a few, but eventually you'll get to this binomial distribution. Click the OK button. The numbers, that's the 8 that we're talking about. How many trials? We had 10 people. Our probability was 0.2. Cumulative, reminding ourselves that cumulatives means from 0 on up to that value. So here we want to type in the word false. So false. And if I get this number, you'll see 7.3. Well, you might freak for a little bit. Wait a minute. And it's like e to that -5. That means moving that decimal 5 places over. So it is in scientific notation. Excel does put things in scientific notation. So just be aware that that is 0.0000737, roughly speaking. So it is the same thing that we had before. Here we want to go strictly less than 4. So again, I'm going to go in, find my binomial. The numbers, I'm not going to put in the 4, because if I want to go strictly less than 4, that means I want to go up to and including 3. Out of my 10 people, 0.2. And here I want to type in the word true. And I want to make sure to type it in correctly. And OK. And there's our 0.87912, and so on. So there's just another reminder of how we can use Excel to help us with these problems. Google Sheets would also be very similar to this. So you feel free to check that one out as well. We're going to go back to my other screen, and I want to continue this idea of the binomial and move into just kind of completing the binomial piece and ask another question, okay? And I want to know, what is the mean? Or the average, average number of people we can expect will prefer whole milk. Okay, so how many on average do we expect to prefer that whole milk? And some of you might say, well, I don't even really need math or statistics for this because, well, and you shouldn't. And so when I write the formula down eventually after we talk about this, the formula is going to make sense. So we know that 20% of all consumers, we have 10 people. So our mean, or it makes sense that we want 20% of our 10, which is 0.2 times our 10, which is 2. So out of our 10 people, we expect 2 people to prefer that whole milk. And if you can remember the graphs when we were looking at them, 2 was the one with the highest probability. Okay, so it does turn out that the mean, if you're looking at the mean of a binomial, and I'm going to put X here to refer back to the X that we're talking about in this problem. To calculate the mean of a binomial, all you have to do is take your n, so that 10, and multiply it by your p, which was, you just got to multiply those together. It also turns out that our formulas for the standard deviation and the variance are also quite easy. I'm just going to put the standard deviation here. So our symbol for the standard deviation is that sigma. I'm going to again put the X down here just to refer it to this X that we're talking about here in this problem. It does have a square root symbol in it, which shouldn't surprise you. But it is a lot less complicated than adding a bunch of stuff up and squaring things and subtracting things and all that kind of stuff. All you have to do is take n times p times 1 minus p and then take its square root. So for this problem, we would actually just take our 10, multiply it by our 0.2, multiply it by that 0.8, multiply all those pieces together and then times the 10. So, and then go to your calculator. And you should get the value 1.2649, and there's more digits if you want to. But make sure that you understand that this is the formula for that binomial distribution only. It doesn't work all the time for every situation, but this is a nice one. We do get that nice mean, n times p, and our nice standard deviation. So that kind of concludes the binomial distribution. So hopefully you learned a lot. Hopefully my videos are helping. Thank you.